Hello everyone, this is Felix from GMWolf, and today we're going to be looking at the actor action model and how we can use in GameMaker Studio. But before we start, let's have a look at what is an action actor model. So simply put, it's a way to organize your code in order to separate the different actions or the different pieces of logic that an object can have. Let's compare it to the traditional naive approach that most of you are probably using. So first of all, in the naive approach, what you have is both the state and the logic in your main game objects. This is different from the actor action model where you have separate objects for the state and the logic. Now what this means in the naive approach is that we have lots and lots of different variables for each of the states, also lots and lots of code in each of our scripts, making it quite hard to see. You may, for example, have an object which can move around and it can perhaps also attack. It may have variables on how it's moving and also what it is attacking. Now this is again different from the action model where all the different state variables are actually separated into each of their action objects. Now what this means is that the naive approach can often be a lot less flexible because every time you have your code inside one object and you want to use it somewhere else, you pretty much have to copy it over along with all of its state variables. It can also be a lot less sustainable because you end up with very large pieces of code and objects with a lot of different variables, and they get more and more complex as you give them more and more behavior. Again, this is remedied by the action actor model because you have a lot more flexible system allowing you to reuse actions for each of your different actors as you like, and it's also a lot more expandable because you can add more actions, as many actions and actors as you like, and they'll never really get in your way because you're only working on one action or one actor at a time. Now let's have a look at the objects quickly that we're going to be having. We're going to have actor objects. These have no or maybe very minimal logic, so you wouldn't have anything about movement or anything. You may just have some simple logic to do with drawing the sprites and so on, and it will also store global states. So no state to do again with how it's going to move or where it's going to move, maybe only simple state like its sprites and its current location. Now the action objects will be different in that they'll hold only logic and state for each distinct action. So you may have one action which is moving the player around, and that will hold information about where it's moving to and also the code as to how it is moving. It's also going to hold a reference to the actor it must affect. That is in order to change the state of our actor. Now, this may be a little different if you've used other engines out there, such as libgdx, and there's a few others which also have the ability to use action actors, where generally speaking, your actors will hold a list of actions. Now, but in GameMaker Studio, it's a lot easier to do it the other way around. Now, the question is, when should you use actor actions? Because they're not really a universal tool. Much often, the naive approach is a lot more reasonable. You would use actors and actions when your objects are not directly influenced by the player and have orders in a way where, for instance, you may be making a real-time strategy game and you may have units which can move around, maybe attack, but they really only do a few of these things based on orders, and you give them an action once and they'll go ahead and do it. So this is actually a perfect fit for it. So without any further ado, let's get going and seeing how we can code this in GameMaker Studio. So this is the project we're going to start off with. I just have two sprites and that's it in order to represent all different actors. Now we're going to start off with a simple actor at first, which is just going to call O actor. And what's nice about GameMaker Studio is that we already have our X and Y variables defined. It will already be drawing the sprite on its own. All we have to do is select the sprite and we're done with our actor. Now we can create a new object for our first action. Now the first action we're going to create is moving from one point to another. And we're going to call that action O, action move. Now we don't need a sprite because it won't be drawing anything. However, we do need a create event where we can initialize our code. So let's actually write this in the description. We're going to initialize the action. So what we want is a destination we can go to, and we're just going to use two simple x and y variables called x2 and y2. Now we're going to set them to 0 to begin with because we don't yet know where we want our object to move. The next thing we need is a speed the object can go at. Now, the speed variable is already taken by GameMaker, so we can't reuse it. However, we can use something like underscore speed, and we're just going to set it to 0 because once again, we don't know the specifics of this action yet. Finally, we need to know what actor we're going to influence, so let's quickly create a new variable, name it actor, and for now we don't know what actor we're going to affect, so we're going to set it to no one. Now we can actually create the logic part of this, and we're going to put everything inside the step event. So this here will be moving the actor. The first thing we want to do is make sure there actually is an actor, because if there isn't an actor, then we're going to have errors later on as we try to get the position of the actor and so on. So we're going to write if instance exists actor. And in here we can now actually manipulate our actor. Now the first thing we want to do is get the distance and direction from the current actor's position to the target location. So the way we can do this is by creating a vector, or in simple things, you can think of it the difference in x and difference in y. So we're going to call it dx is equal to x2, which is going to be our destination x location, and actor.x. Sorry, minus actor.x. Now we can do the same with the y coordinates, saying that our difference in y is y2 minus actor.y. So now we have, in a sense, the direction we want to go to. However, we don't really know the distance yet. We only know each component, x and y. So we can get the distance by saying var dl equals the square root of dx times dx plus dy times dy. Now this is just Pythagoras. We're just looking at the hypotenuse between the x and y axis. So now that we have the length, we can actually check if our actor is close to the target location. And so we can check that with a simple if statement. We can say if the dl is smaller than underscore speed. Now we're using underscore speed because it will, instead of 0, because otherwise we'll have our object overstepping our destination. It may step over or every time and then keep alternating between going too far and not far enough all the time. Now we're going to leave it at simple like that, so it won't be entirely accurate where it will end up, which is okay for most games. However, in here you could also have a bit more code to actually snap your object to the target location fairly easily. Now what we're going to have in here is simply say that if we are at the location, which for us is simply saying if the distance to the location is smaller than our speed, we're simply going to destroy the action. We don't really need this action anymore because it is done executing. Otherwise, we can start moving our player towards the point. Now what we have here is a dx and dy, which are different in x and different in y. However, we want to be able to normalize it, and what this means is having it so that the distance combining our dx and dy is only 1. This way we can actually get our object to move at a constant speed, and this is actually quite simple to do. All we have to do is divide our dx and dy components by the previously calculated length. Now we already know that our distance is not 0 because we checked that it's actually greater than speed. So here we have it, dx divided by dl and dy divided by dl means that our vector is now properly normalized. So now that we have dx and dy with a length of 1, we can simply do actor.x plus is equal to dx times underscore speed, and actor.y plus is equal to dy times underscore speed. This way our actor is going to be moving by exactly underscore speed in the direction of our target. So this is essentially it for our action. We can actually save and create a quick test object to make sure that our action and actors are moving. Now unfortunately with this system it's a bit harder to use the room editor, so we're just going to create, as I said, a test object to quickly see how this is going to work. In the create event we're going to create our actor. So I'm going to say var actor is equal to instance create layer, and let's just make this longer so you can see the code. The X, we're just going to use the X and Y position that our test object is going to be placed at on the same layer, and the object is going to be O actor. Now we can create our action, which I'm going to call O action over here. And again, we're just going to do instance create layer, and it doesn't really matter where the position is, so I'm going to put it at 0 and 0, the same layer, and our O action move. Now we need to actually give parameters to our action, so we can say action.x2, and we can set that to some number like 250, and action.y2 is equal to 250 as well. Finally, we also need to give it a speed and actor to actor pawn, so we could say action.speed underscore speed. Let's set that to a number like 4, and action.actor is equal to actor, the actor we previously created. So if we can save this, we can actually add our test object to our room. We can put it in the top left corner, press run, and what we should see is our actor moving towards 250 until it stops, because our action object just got deleted upon completion. So it's working just fine. Now what we can do now is actually have the ability to give our actor some orders. Now what's interesting to note is that actions don't necessarily have to be active things. They can also be listening for events and so on. So what we can do is quickly create a new object, if I press the right button that is, which we're going to call O action click. So this is an action which is going to wait for us to click on a location, and it's going to tell our actor to move to that location by creating our action. So all we do is actually have a create event which is going to have our actor. So here will be init, and all we need is our actor, and we can set it to no one. Now instead of creating a step event, we can have a global left pressed, which is going to be triggered every time we press, and we're going to basically order unit to move. So again, we need to check whether our instance exists. So we say if instance exists, our actor, then we can actually do something. So we will basically create our actor first. So we can say var action, our action first. Var action is equal to instance. Again, let's make this longer so you can see the whole code. Instance create layer. It doesn't matter where it is, the same layer, and our object, which is O action move. Now we can actually set up our variables. So action.x2 is going to be equal to mouse x, so it moves where our mouse is, and same with the y coordinate. Next we want the speed. Now a speed of 4 seemed about right, so we can say action speed is 4. And finally the actor we want to influence, so we can say action.actor equals actor. Now finally, we don't want to have our multiple actions at the same time or anything, so we're just going to do instance destroy. So when you click, the actor will the action for clicking will no longer exist. So what we can do inside our test object is actually remove this whole speed and x2 and change the creation of our action to be action click instead of action move. And now if we run and see what we can do, we can click anywhere and our object will now move towards that point. Now I can click anywhere else, but because our action click has been destroyed, it doesn't respond anymore. So we can go ahead and save this just in case, and now we can have it so that our action can still be triggered after it completes. And to do this, and after destroying over here, we can actually say that we're going to create a new action click with the same actor again. So we can say var action is equal to instance create layer. And at this point, you probably got the point. We're going to write, if I can move my view around, we're going to say that the position doesn't matter on the same layer. And finally, the object is going to be O action click. One thing we need to remember to do is to set our actor such that the new actions actor will be this very same actor we're using in this action. So now if we run, we can click anywhere and our object will move towards here. And once it stops, we can click somewhere else and it will move there. Now one thing you may notice it's a bit offset every time. That is because I forgot to center the origin of the sprite. As you can see, it's always at the top left corner of where I clicked. So this is already a pretty simple way to see how we can use actors and actions. Now what's interesting to note is that we don't have to stop here. We can have multiple actions running at the same time. Now to demonstrate this, I'm actually going to switch up the sprite to a square. And this will run exactly the same. But what I'll do is create a new action. Call it O action spin. And what we can do in this action is spin our object just to demonstrate that we can have as many really actions as we need. So in here we can say init, and all we really need is our actor. So actor equals no one as usual. And inside our step event, we're just going to spin our object by saying that if instance, if I can spell that right, exists, and our object is actor, then we're going to say that actor.imageAngle plus equals some number like 15, for instance. Now we need to get our actor created, so inside our test object, we're going to say that var spin action equals instance create layer. Again, like usual, 0 and 0. Let's move the view over so we can see the same layer, and O action spin. We can say that our spin action dot actor is equal to actor. If we save and run, we'll see that our actor will start spinning around its origin, which I forgot to center, so it looks a bit wonky. However, we can still have multiple actions running at the same time. In fact, to make this a bit easier to see, let's properly center our sprites, and with our circle as well. And run this again so we can see everything running in a bit less funky way. So as you can see, it's spinning around its origin now, and it's still being able to move in different points. So as you can see, we can keep stacking on more actors and actions. We can create more actions and have them run at the same time or not. It really is quite a flexible system. However, just to show that we can actually have our actors share the actions in any way we like, we're just going to create a quick test object, actually edit our test object, and simply create another actor, say, in fact, let's first create our new actor. Here we go. O actor 2. let's go back to our test object. We can say that var actor2 equals instance create layer x, y. Actually, let's put it somewhere else. Let's do x plus 50, y plus 100. O actor 2. We've got to set the layer. Layer act 2. Let me just make this bigger so you can see the full code. And then we can say that we want an action for it. So var action click 2, for instance, equals instance create layer 0, 0 layer O action click. Now, as usual, we have to set up our actor correctly, so we can say action click 2 dot actor, and that's going to be equal to actor 2. And now if you run it, we'll be able to see two instances, each with their own sprite, and they both respond to our actors that we set up. Now, as you can see, this is an incredibly flexible system. You can have as many actors as you want, as many actions as you want, and the code is always really self-contained. We don't have to see the spin code when we're dealing with our clicking code, and so on. So I hope you have enjoyed this video and found it useful. If you create anything cool with it, please let me know in the comments down below, which is also where you can go and ask any related questions if you have any. And if you've liked it, please give a like and subscribe, and I'll see you guys next time for some more GameMaker tutorials.